This next equation that we're going to solve here is going to require something a little bit different than we've had to do in the previous examples. In the previous ones, we've seen that you can add, divide, subtract, multiply by things sometimes to isolate that trig function, right? We've also seen that you can factor to isolate the trig function. Another way is we can use trig identities. So you might remember that you have an identity, a double angle formula, sine of 2 theta is equal to 2 sine of theta cosine theta. Now, we don't have 2 sine theta cosine theta, we have sine x cosine x. So the only thing we'd have to do to adjust this equation here is to divide by 2 or multiply by 1/2. So 1/2 sine of 2 theta is equal to sine of theta cosine of theta. Let's see what this has done for us. This means that we can rewrite sine x cosine x as now 1/2 sine of 2x is equal to the square root of 3 over 4. Okay. Now we just have a single trig function. This is good. Okay. Let's multiply by 2 on each side. We have sine of 2x is equal to the square root of 3 over 2, because 2 times 1/4 is 1/2. And then next we're going to think about on our unit circle where or for what angles is sine of x equal to the square root of 3 over 2. So one of those places would be pi over 3, right, and then plus 2 pi n. And the other spot would be 2 pi over 3 plus 2 pi n. And we can go ahead and divide both of these by 2, and we get x is equal to pi over 3. And that should be a pi over 6, right? Because we were dividing by 2, so pi over 6 plus, and then 2 pi n divided by 2, this is going to be pi n. And over here, when we divide by 2, we should get pi over 3 plus pi n. So these two little formulas down here, which I'm going to only box these for a second, these two formulas here give us all the solutions to this equation. But once again, we only are actually concerned with the interval from 0 to 2 pi. So what I'd like us to do is just maybe start off working with this formula. Okay. And I'm going to actually also write in here solutions on 0 to 2 pi. Okay. What do these look like? So if we were to say try and plug in n equals -1, I just want to point out that it's going to be smaller than 0, right? X equals pi over 6 plus pi times -1 is equal to pi over 6 minus pi, which is minus 5 pi over 6. Point is, it's less than 0. And we'll have a similar thing happen if we use the formula that we have here on the right. If we were to plug in n equals -1, we would also get a negative number, which is not between 0 and 2 pi. So we don't want to plug in any negative numbers for n. Let's start off with maybe 0. Okay. If we were to plug in 0 for n, we'd get pi over 6. And if we plug in n equals 0 here, we'll get pi over 3. Now let's think about moving up to n equals 1, right? We've plugged in n equals 0 so far. If we were to plug in n equals 1, for this first one, we'd have pi over 6 plus pi, which is 7 pi over 6. And if we were to plug in n equals 1 into the other formula, we'd have pi over 3 plus pi times 1. And when we add these together, we get 4 pi over 3. Okay. Now let's bump up one more. Let's try and plug in n equals 2. Okay. If we were to plug in n equals 2 into, say, the first formula, we'd get pi over 6 plus 2 pi. And you can see this number is already bigger than 2 pi. So this isn't going to be of any use to us if we're only looking for answers between 0 and 2 pi. And the same thing can be said with the second equation. If you try and plug in n equals 2, it'll be too big. And so these are all of our solutions on that interval from 0 to 2 pi. All right, so we've seen two different tricks now for solving these trig equations, right? We could use a little bit of algebra, specifically so far mainly just adding, subtracting, factoring. Okay. Then we've had these trig identities that we were able to use here. Right? We used a double angle identity for sine of 2 theta. In this next one, we have one more trick. Okay? We could try and use a few different techniques on this one, but the only one we're actually going to find is going to work is by squaring both sides of the equation. Now, when you do square both sides of an equation, you do have to be a little bit careful about something. And here's why. Let's say that you started off with a equation that was not true, or you started off with two numbers that were not equal. Let's just say that. Well, if you were to square each one of these numbers, they happen to be equal. Okay, and so we essentially have to watch out for this happening here. When we get our answers from solving this equation, we're going to want to plug them back in and make sure that they actually satisfy the equation. Okay. And these are called extraneous solutions. That's what we're looking to weed out here, our extraneous solutions. So if we go ahead and square this then, we get sine squared of x plus 2 sine of x cosine of x plus cosine squared of x. So we're just foiling here, sine of x plus cosine of x multiplied by sine of x plus cosine of x. And then this is all equal to the square root of 2 squared, which is 2. Okay. And you might be wondering, well, how would somebody even think to try this? Okay, and here's how somebody might. They might look at that sine x plus cosine x, and they might actually start off instead by trying to use maybe a sum to product formula. But then they'd realize that this product of trig functions equal to the square root of 2 is causing us to not be able to solve the equation. So we need to try something different. Okay. And you might notice if we do square this equation, both sides of it, that we're going to end up squaring sine and cosine. And we know that sine squared x plus cosine squared x is 1. So squaring this might make some nice simplification happen. And it in fact does. Okay. So sine squared x plus cosine squared x is equal to just 1. So we have 1 plus 2 sine of x cosine of x equal to 2. And from here we could subtract by 1 on each side. And if we do that, that gives us 2 sine of x cosine of x is equal to 1, because 2 minus 1 is 1. And then finally, we could divide by 2 here. And so we get, if we divide by 2 here, we'll still have that a product of trig functions here. Okay. Why don't we use the fact that 2 sine of x cosine x, we just use the fact that that's equal to sine of 2x like we did up above. So now we have sine of 2x is equal to 1, and we just need to think about where this happens at. Well, this happens at x is equal to, right? And actually, I'm going to say 2x because we want to know what things plugged into sine will result in 1. And that would be angles that look like pi over 2 plus 2 pi n, right? Pi over 2 is the top of the unit circle, so y should equal 1 there. And if we were to go another step further, we could divide by 2. This gives us pi over 4 plus pi n. And now we could start plugging in values for n like we did previously. But let's just write down that we're writing down the final answers here now. So solutions on 0 to 2 pi. And if you were to plug in n equals -1, this would be negative. If you plug in n equals 0, we get pi over 4. I'm going to write x equals pi over 4. You'll also get x equals 5 pi over 4 if you plug in n equals 1, right? And then we can try to move up to n equals 2. And is what we would notice is that the result here is going to be bigger than 2 pi because we already have a 2 pi in here, and then we're adding pi over 4 to it. Because what this means is that all of our potential solutions are right here. And I did use the word potential for a reason here. Before we finish this problem, we need to check for extraneous solutions. So in other words, because we squared both sides of the equation, it is possible that one or two or none of these solutions satisfy the equation. And there's only one way to find out, and that's to actually take these and plug them in. So we actually need to check. You can actually use your calculator, but so let's say we were going to check that x equals pi over 4. Then this is going to look like sine of pi over 4 plus cosine of pi over 4. And if pi over 4 is actually a solution, then this should equal the square root of 2. Well, let's see. The square root of 2, or sine of pi over 4 is actually equal to the square root of 2 over 2. And so is cosine of pi over 2. And if you were to add those together, let's actually maybe for a second say we're still wondering if these are equal. You would get 2 square root of 2 over 2. And maybe you're still wondering. And you might notice now that those 2's do cancel, so we end up with the square root of 2 equals the square root of 2. So x equals pi over 4 is indeed a solution. Okay? But we also need to check for 5 pi over 4. Okay? And I would be fine with you doing this checking process in your calculator. But let's try out the other one. Let's try 5 pi over 4. Okay, so we want to know, does this equal the square root of 2? So sine of 5 pi over 4. This is all the way in quadrant 3, which means sine and cosine are both negative. And so these are both then going to be minus the square root of 2 over 2. And if we were to add those two together, that actually will not give us the square root of 2. It'll actually give us minus the square root of 2. So x equals 5 pi over 4 is not a solution. It would be called an extraneous solution. So we actually only have one answer in the interval from 0 to 2 pi of that original equation, sine of x plus cosine of x equals the square root of 2.